protection. When you guys get into the electrical system, you're gonna see that there's a lot of protections that we do. One notoriously famous is called overcurrent protection devices to protect the public like us and the buildings from being burned from electricity. That's overcurrent protection device, fuse or circuit breaker. Now moving forward, there's other, and if you are lucky enough to do medium voltage like you, young fella, doing with Excel Energy, you're going to be doing, they do their over under voltage, over under frequency, directional overcut. There's tons of things that we do to protect the power system, to maintain the integrity of the power system. Most of us deal with overcurrent protection device. A couple of other places that we use protection is called GFCI. You guys are familiar with the GFCI before? So that's one way of protecting people from electrocution, protecting from shock hazard. If I grab on a hot and I'm grounded, I grab on a pipe, I get shocks, right? So this device is meant to protect you from electrocution. Can I have thumbs up like you do? The second one is arc full circuit interrupter. This device is meant, no electrocution here. This device is meant to protect you from a fire initiated and activated by electrical arc. So you have a loose connection there. The loose connection sits there and arcs. If you have some type of some type of combustible things around it, you will ignite the surrounding and create a fire. So that's one of the reasons, Aaron, that we have boxes in the electrical industry. We put things, termination boxes. But the problem that what happened is the extension cords that you have right here in front of you, if the extension cord, and imagine in every house in America, extension cords are all over, you pull and push things over them, you abuse them. So if they get freighted and they're plugged in, they could arc. You could have a line series arc or parallel arc. Series arc, say the hot is barely broken and it's just conducting enough to get things to flicker and creating the arc, right, which is heat, and it's sitting right under your couch. So could that create a fire? Yes, that's a series arc. Parallel arc, guys, what if the hot and the ground are barely touching, slightly touching, and creating just enough juice to go through and create an arc, right? That could create a fire. The smarter than Chad decided to put arc full circuit interrupter right now that protects you from this. The third protection that we use is surge protective device. Surge protective device, guys, you get hit by lightning on a transmission line, your voltage looks, it was perfectly fine up to this point, and then hit by lightning, it went all the way up to the Lord, down to the devil, and came back again, and started going up and down like this, and then the lightning went back to normal. That's what, this is called spike in the system. Now you take this spike that went to the Lord, down to the devil, right into your equipment. What does it happen to your equipment? Burn it. So this device, it takes this and cuts it, get rid of it. And it comes over here and cuts the stuff down here. So it takes the spike, the high voltage, the extremely high voltage for a very short amount of time. That's what a spike is. And basically eliminate it, shunt it to the ground, and save your equipment from being burned. Now GFCI wouldn't do that. Circuit breaker wouldn't do that. Arc full circuit interrupter wouldn't do that. Does that make sense? What this particular device is doing? The last one, so everybody's okay, so I have protection number 1 and protection number 2 here. Protection number 3 is the surge. Protection number 4, they call it appliances. These two called appliances, circuit interrupter or appliances leakage current interrupters. We don't do this. The manufacturers do this. So can I unplug this one? What they do, guys, the plug that you use for your air, what do you call that? You groom your hair with all the appliances. Imagine somebody drop the, what do you call things that you groom your hair? Hair dryer. Thank you. The hair dryer that you use, and somebody accidentally or intentionally or both dropped that one while energized in a sink full of water. So you could hurt somebody. That manufacturers, remember, you are manufacturing products for millions of people. Some of them are dumb, some of them are good, some of them are ugly. So what they do is they have a device right in here. They call it earth leakage device, which is detection circuit interrupters or appliances leakage. So if it sees any leakage to the ground because of that action of dropping the appliances into the water, it will, there's a mechanism here, it will trip and isolate the circuit. So we don't really do that much with it for ourselves, but this is the manufacturers. So protect people from electrocution if they drop the equipment down into a water. Okay, so that's basically what we did. So we talked about the arc full circuit, GFCI, arc full circuit. These are the two ones. These ones are manufacturers. This one and this one are almost the same, done by manufacturers. We'll talk about where do you need, so for us, really the GFCI and the AFCIs we're going to talk about, and detection. Where do we need them in the code? They shouldn't share neutral. Everybody knows that these have to, you bring the hot to the arc full circuit interrupter circuit breaker, a hot and a neutral, and you take the hot and a neutral from the other end. So you can't share a neutral. Otherwise, we defeat the purpose. Defeat the purpose of shared neutral on these equipments. So these are what we're going to be talking about, guys. Also, since we're talking about dwelling, I want to draw your attention to the term tamper-resistant receptacle. All the receptacle in a dwelling must be tamper-resistant, and you guys have seen that. All of them, no exclusion. When I say all of them, I mean the 15 and the 20 at 120 volt. These are the most common receptacles. If you have a 2-4 receptacles, they don't have to be tamper-resistant. So we don't get too much into replacing GFCI. GFCI replacing, we'll talk a few things about these. Construction site, I do this in a commercial. On a construction site, there are rules, guys, for wiring and construction light. I'm going to mention it, but we'll do it mostly in when we get into the construction site. And the last thing is surge protective devices. Now, before we go into the surge, we'll talk about surge protective devices that protect you from the surge. Okay, so again, this slide is just to summarize why do we need all these protection. GFCI protect you from shocks, being shocked, right? By interrupting, if there is a difference in the current, what's in, what comes in, what comes out. Substantial difference, 46 milliamps, instead of going through Chad killed his heart, sending him to join his mom in heaven and his dad in hell. It will trip, or his dad in hell. Oops, sorry, Dad. So that's what's supposed to do, to protect you from electrocution. Everybody knows that. Shock hazard, touch hazard. We'll talk about this one. This is just a few things, guys. Talk about internal damage to the organs if it goes. If anybody wants to go into the safety, I know we have a project manager here. Check my, I have a 70E, 4 hours of 70E training that we did for my clinic on my YouTube channel. 70, it talks about in details about shock hazard analysis and arc flash analysis. So this is to protect you guys from shock hazard. When you have a shock, surprise, here's the element that affect you guys when you get a shock. Number one, as the circuit characteristics, do you have an impedance between you and the source of power? If you have an impedance, it will limit the amount of current coming and cooking me, basically. The second thing is the body resistance. Are you fat and fluffy? So this is where fat and fluffy becomes a big deal. You can handle more current going through you versus skinny people. That's one advantage of having some meat on you. Contact duration. Do you get in touch with the circuit and you sit there for an hour? Or did somebody de-energize you when you grab some hot on the ground, right? Look, now you can imagine if the impedance is low and your resistance is low, you're cooked more. And if your contact is long, you cooked more. Pat, where does it go? It goes right hand to hand through your heart, send you up to heaven, right? Or it goes leg to leg and cooks your organs down there. Humidity too has effect on it. So all these guys make a big effect in electrocution. You guys know that. You're not doing that one. So the rule of thumb, guys, the code, not the rule of thumb, the code, anything 50 volts and greater is considered lethal. Though you can get lethal at any voltages. But typically if you have the code, anything 50 volt or higher, we ground the system and we consider it lethal voltage. So if you have a 24 volt, not lethal voltage, though it could torture, it could hurt, but the lethal usually stand at 50 volts or higher. So based on amps too. Based on amps. But in order for the amps to move, you need a pressure to push the amps. that's where the voltage becomes a big deal. You can have a certain amount of amps, and in order to push them, it becomes lethal to push these amps right through you if the voltage goes higher than 50. Does that make sense? Voltage, guys, is the push, the one that push the amps. The amps are great. Bigger amps will kill you, but you need somebody to push these amps. It becomes lethal in terms of pushing the amp through your body or through anything else when the voltage goes higher than 50. And this is why we require 50 or more to be grounded system. Grounded system. This is really an interesting graph that we have. GFCI is supposed to trip. This is your GFCI. It's supposed to trip within 6 milliamps. 4 to 6 milliamps, and it's not just the. Are you guys okay? It's not just, guys, the trip. It's the time. Look at the time. It's supposed to trip within, will open in from approximately 0.035 to 0.1 second. So here's what I would like. So we have 4 to 6 milliamps, and it opens from 0.035 to 0.1 second. Can I guys get you just to look at these? Why it's GFCI protects you? First, because it only allows up to 4 amps to go through your heart, and that's probably, you can survive that one. Goes higher than that, it opens. So it picks up 4 to 6 milliamps, number one. Anything higher than 4 to 6 milliamps, you will open. But look at the second opening. The second thing is how fast it opens. It can open from 0.035 second to 0.1 second. So long story short, it handles two very important things: the amount of current that goes through the person and how long you allow the current to sit in your body. Anyway, so there's this curve that they use. This is the curve where it trips based on the amount of current. You can see this is where, if it reached this point, that's where you go to the, like this is will be what, time in seconds. If you allow this amount of current, this is what where are we here? That would be like, see, 100 and between, where are we here? Between two values. We're between 180 and 100 and 200. So let's just go to 180. So if I get 180 milliamps through your heart for a second and a half, we will send you to the second life. Does that make sense? How this red is where you do not want the amount of amps to be that high for that long. So they use this chart. The only thing you need to remember is the tripping, how slow it trips and how fast. So that's your tripping. If you have, the code requires all these two systems up to here to be grounded. So do you guys remember safety start with what? With having a grounded system. The system is grounded and the equipment is grounded too. You have a grounding conductor that ground all the equipment. Then you have an overcome protection device to protect the circuit, and then you have to have GFCI to protect you from being electrocuted from the most convenient amps, 120 to 120 voltage and 15 amp and 20 amp circuit. Why do we ground the systems? Enhanced voltage. When I say grounded, guys, here's a delta here. I mean a Y. Here's my grounded system. So here's the system is grounded, and I'm also pulling a grounding equipment, grounding conductor with it. And I'm pulling here grounding electrode conductor. That's what they're talking about. That's the safety that inherently in the system that we use. This is 3-phase, single phase, very similar. You grab this in the center, you ground that boy here. So here's your, here, and then you grab this, the frame is equipment, grounding conductor, and you have 4 conductors going, right? You have hot, neutral, and a ground. That's what the systems are grounded. Any comments, guys, why the ground system 50 to 1,000? Safety in conjunction, of course, with the ground fault. In conjunction with the ground fault. Okay, let's talk about location for GFCI since we are doing dwellings. Location for GFCI, all receptacles, 15 and 20 amp, 120, have to be GFCI in the following location, in a dwelling. Anybody can repeat after me? Bathrooms, not repeat, but bathrooms, kitchen countertops, right? Within 6 feet of every sink, the bathrooms, countertop, and within 6 feet of any sink, unfinished basement, outdoor, any place where you have water. Why? Because water with electricity, guys, is lethal. What else? Did we forget anything else? So these are any place where there's water or dampness, need a GFCI. In a dwelling, that will make you within 6 feet of any sink, kitchen countertop, bathroom, unfinished basement, and outdoor, and garage. Everybody got that one? Okay. In a non-dwelling, for the most part, the same thing. Within 6 feet of a sink and everything outdoor have to be GFCI. So that's where your GFCI location. If you want to know where GFCI location guys are, you're looking at water. Every location there's a water, there's likelihood that the shock will be lethal. Electricity next to water, a shock is lethal. Just think about it. If you have to guess any place where damp or wet location, that's lethal. If you have a receptacle at these voltages, we need them to be GFCI. The code allows you guys to have a GFCI on the feeder. So if you have a GFCI on the feeder, actually, we don't use it commonly. We typically in the US, we use a lot of GFCI directly into the devices. Now, believe it or not, Joe, my friend, that's how I wired in Jerusalem myself. They allow you there to put the GFCI right in the feeder. And see 100 amp here, and you put GFCI, or earth leakage they call it, and rate it for 30 milliamps though. So what happens if you have enough leakage in your system? This will trip. If it trips, you lost power for the whole house. That's why we use it here. We distribute the GFCIs. I think it's a better way. So if a GFCI is the trip, you don't lose your lights. So just be aware that you can put them on a feeder too. Now, in dwellings, you don't need a GFCI for fire alarm or burglary alarm system. So that's an exception. So in your basement, you have one receptacle, you plug in a fire alarm system or a burglary alarm system, excluded from GFCI. GFCI, you can have them breakers. Typically, we don't use a whole lot of GFCI breakers, but you can have GFCI breaker that protect all the area, or you can have receptacles. What we typically use is what? Receptacles. Okay, got that one. A lot of GFCI receptacles are feed through, and we have a couple of pictures we'll show you guys. You bring line in and load out, and you protect it. And this is a GFCI have to be tested. So there's test and reset monthly. You're supposed to go push the button, test, reset, make sure it works. Any comment, guys, about GFCI before I move into the AFCI? So that's basically what the GFCI notes. A lot of it is review for you. Otherwise, I'll spend a lot of time more on that.
I had a teacher that used to teach how they worked. He used to take a hot GFI and plug the cord into it, hold on to the hot of the cord, and throw it in a bucket of water to show that it trips and you don't feel it.
Oh.
Same thing as like from a hair dryer.
You hold in a bucket of water.
No, he would put a cord plug, cut the end off.
Suicide cord.
So yeah, suicide cord. He'd be holding on to that, and it would be plugged in.
Holding on the hot.
GFCI,
holding on the hot.
Plugged into the GFCI.
Yep.
Throw the GFCI in a bucket of water.
Through the GFCI.
Yeah, it was just a
portable.
bare thing that he had made up with another cord to the GFI. And
interesting.
To show that it trips off.
It trips.
Before you feel it. And everybody's like,
yeah.
You sure that thing works? What's that?
I know it works, but I wouldn't do it myself. Okay, so GFCI. The first line of defense is GFCI to protect people from shock. The second line of defense right now is called the AFCI. AFCI, we talked about AFCI, guys. Here's what AFCI looks. Take this. Your signal looks beautiful like this, right? Look how nice and beautiful. Now, Brian, because he abused an extension cord that plugged into one of his outlets, really abused it, moving the couch and dropping it right to the top of it, so freighted, and it starts arcing. So when it arcs, instead of the sinusoidal looks like this, this is how you're going to see it. You're going to see something and I'm just creating this. The signal will look something like this. You and I care less because we don't see it. The smarter than Chad, take this signal and study the arc, different arcs, the manufacturer of arc fault, and create an electronic circuit that sends that signal, number one. Number two, identify it as an arc. Number three, open the circuit before you create the fire. That's what supposed the arc fault circuit adapter do it. Now there's a lot of nuisance tripping because this signal could come from old equipments and so forth. But the arc fault circuit interrupter is supposed to protect you from burning a house. So that's why we use them a lot in residential. We don't use them at Dunwoody here because typically these are institution. Hopefully they have maintenance and people check it. Homes, guys, are abused all the time. Look at your house, right? You just said the conduit is basically a water pipe coming to your basement. So that's why we have them. Typically right now they're all circuit breakers, though they're working on a receptacle to be done. And they protect you, GFCI from shock, AFCI from fire. Everybody's okay with that one? Know that? Okay. Here's the location where you need an arc fault circuit interrupter. So in our project, Aaron, my friend, you're going to list all the circuits that feed all these areas, receptacles and lights, as what? Arc fault circuit interrupters. And what's the difference? $7 for a circuit breaker versus what? Almost $35 to $40. The difference between arc fault circuit interrupter circuit breaker and a regular 15 or 20 amp circuit breaker. Okay, so in every family room, I can't emphasize this is for lights as well as receptacles. Lights and receptacle in all these areas. So family room, dining room, living room, parlor, library, dens, bedroom, sunroom, recreational rooms, closets, hallways, other locations like gun room. Yeah, my brother-in-law has one. Gun room or other areas, believe it or not, serious, I'm not kidding. So whatever other area similar. So the way I understand it, guys, this is always needed in places where there is no GFCI. Think about it. Is there a kitchen here? GFCI. No, it's not here. Is there a bathroom here? No, it's not here because it needs GFCI. Laundry room? No, not here. Unfinished basement? No. All these are what? GFCI. Outdoor receptacles? No. Garage? No. Crawl space? No. Can you guys see how you distinguish between the two? Where GFCI is needed, almost AFCI is not needed at this moment. Now, can you put AFCI and GFCI on the same protection? Yes. No problem. Okay. The second thing is that they require is tamper resistance, TR receptacles right now. Tamper resistance because of children like my friend Brian's kids, not Brian, Brian's kids, children, because paper clips in the hot. I had a guy in one of my classes say that when he was a kid, he's an electrician now, he said he took his dad's key and stuck it into the hot slot and he got a big arc out of it. So kids are creative to prevent people from pushing things in the hot slot, guys, and while sitting in a basement, bare feet, barefoot, and damp basement, that's perfect shock for a child.
That's what I was doing too. I was standing in the funnel.
When you
water's, running down the pipe through the receptacle at the bottom. So
yeah, but you were not touching anything hot though.
no, but the current could have, in theory, the current could have, went through the water.
But then the circuit breaker will trip though.
But
Because
there's
they're ground fault.
down there, so
Because you have a ground fault though. Well, at that level, it could escalate to a ground fault. You're right. Because if you have a ground fault, a full spiel ground fault, that boy will wake up. But a little ground fault is what GFCI looks at, the tiny little ones. So, okay, children, to insert things, guys, will trip. That's the okay. So whether all receptacles have to be tamper resistance. The second thing they did, guys, is weather resistance. Weather resistance. Now, Joe, my friend, all the receptacles in a damp or wet location have to be weather resistance. In our project, that will be typically all the receptacles outdoor at the swimming pool. The weather resistance, guys, they're made out of material that does not deteriorate with dampness and the heat and cold weather. I don't know how many of you guys, you're not electricians, but Darren, maybe you guys, I open a circuit breaker, a receptacle outdoor to troubleshoot it, and it falls apart in your hand. I don't know if you practice this, especially outdoor ones. It will completely fall apart in your hand, energized. So the material disintegrated over time. So these receptacles are supposed to have a stronger material that doesn't disintegrate. Okay? Where are they required? In wet and damp location. As a matter of fact, everywhere, dwelling, non-dwelling. Can I have thumbs up, Chad? We know we're weather resistance and we're tamper resistance and we're arc flash, arc fault circuit interrupters, and where the GFCI are required. Okay? So if I test you guys on that, you'll ace it. Good. That's awesome. Okay. Existing receptacle. If you're replacing an existing receptacle, grounding with grounding, no problem. This just talks about, guys, replacing a non-grounding receptacle location. If you have a location where there's no ground, right? A non-grounding receptacle. There's a couple of options I'm going to show you in a second here. Temporary wiring. So everybody knows where arc fault circuit interrupters, GFCI, tamper resistance, weatherproof, weather resistance are required, right? Can I have thumbs up one more time before I move into a different topic? Temporary wiring. Temporary wiring could be for decoration, or it could be for the construction site. If you're doing temporary wiring for construction decoration, typically 90 days, construction until the duration of the project. The code says the following, guys: 15, 20, and 30. Oops, look at that, 30. 30 amps, believe it or not, this is a 30, at 120 volt have to be GFCI'd. These receptacles at 20 volt have to be GFCI'd. In a construction site, 120 have to be GFCI'd. If you're using a permanent install receptacle for demolishing a wall, you either have to GFCI this receptacle, or you have to use a plug that's protected with GFCI, a GFCI power strip. So these are for construction site to protect electricians. If you're using a generator, this is in 2011, you're using a generator, 15 kW or less. The receptacles on the generator, 15, 20, and 30 amp, 120 as well as 240, 120, the one has a neutral, have to be GFCI on the generator. If they're manufactured before January 1st, 2011, after January 1st, 2011. Before January 1st, 2011, if you have a generator, 15 kW or less, then you are supposed to plug in a power strip with GFCI protection rated for portable use. So all these are requirements, guys, for construction site. All other receptacle area in a construction site must be either GFCI, other than these, or have to be put on a GFCI assured program. They call it assured equipment grounding conductor program, meaning you have to test them monthly before and after. Monthly, you have to test the GFCI that works, and you have to, so more testing of these receptacles. This applies, I don't want to go even there. This applies, guys, compressor. You have a 240, 30 amp compressor on the site, right? So yours is not GFCI, but it has to be on a ground fault. They call it assured equipment ground conductor program, meaning you have to test that the equipment grounding conductor is working, it's not frayed, and all this good stuff. Any question, guys, about the construction? So construction, 115, 20, they add 30 though. 120 have to be GFCI. Another thing, Adam, my friend, another thing about the ground on a construction site, they also separate the light from the receptacle on a construction light by code. So you can't put on a construction site my lights and my receptacle on the same circuit. Anybody can guess why on the construction site? You trip GFCI, do you really want the light to also trip and you lose? Now you're on a construction site, people are moving with 2x4 around you, and you lost power and bam, they hit you on your head with 2x4. So do you want that to happen? Not to me though. Okay, so that's basically the whole idea of the construction site. These devices, guys, earth leaking devices, these are made by the manufacturer for appliances. The whole idea here, you drop an appliance in the water. We don't install them, the manufacturer install them inside the plug. You plug it into the water, it will sense that there's a water leakage in it. Instead of electrocuting the water and hurting somebody, this is supposed to trap. Okay, so really we don't do much with it. This is just FYI for you, because we don't install them. This is typical of what we do on a construction site, guys. You have your meter, your mains, and you put your GFCI receptacle at the bottom, pedestals. Either GFCI receptacle or GFCI receptacle or GFCI circuit breakers. Surge protective devices. The NDC code book, guys, talk about them in 280. There are different type of devices. We'll talk about them when we go to commercial. Here's how they protect you from transient. Remember that little wave that went up to the Lord, down to the devil, and came back? Chop them up. That's called transient. It could originate there's impulse. Impulse is a transit, originate inside or outside, outside the building. Why? Because the lightning here or the utility switching transmission lines, every time they switch, it gives you pulse. So that's, they call it the impulse. The other one, they call it wavelength. Again, that little wave that goes up and down. This is generated inside your building by your printers and computers and other things. Polluters, basically. All these are polluters, and they're polluting your signal and giving a spike into your voltage that could kill. So, long story short, surge protective devices. Suppose anytime sees anything very high, it always looks at the pulse, guys. They call it pulse. It goes all the way up high, very high, for a very short amount of time. It chops it down. Any question about surge protective devices used, guys? Let me show you a couple of pictures, and then I'll let you run with it. We talked about this. Here's where GFCI, everybody knows, just before I leave, that all the countertop receptacle and within 6 feet of any sink, you have to have GFCI. Can I have a thumbs up? Yep. So we know, Chad, that GFCI. Cool. We know that if you put a GFCI on a circuit, you lost the lights as well as the receptacle. That's why we typically don't put a GFCI circuit breaker. We put a receptacle because we can lose light if you're mixing light and receptacle. Here's what we do typically. Here's what we do, at least in the US. You put your GFCI right in here, right at the end of a circuit, no problem. Now this receptacle is protected from GFCI. Cool. You put a GFCI on the feeder is allowed to, but what the problem if you lose it on the feeder, you lost the whole panel. You don't want to do that. The principle of operation for GFCI, guys, principle of operation is very simple. It looks like this donut. You guys have seen it. This donut looks at the current in and the current out. Any difference between them, 5 to 6 milliamps, 4 to 6 milliamps, guess what? It sends the signal to the solid state circuitry. This circuitry say, now we have a ground fault, Chad is being electrocuted, send the signal to the trip, and it opens the circuit. I'm making it simple, but there's a lot of electronics inside it. Cool? So the difference is, here's what they tell you the difference. Here's the 6 milliamps, there's the difference of this amount, 4 to 6 milliamps, that have gone through somebody's heart and back into the source, right? So that's where the 4 milliamps have gone. 4 milliamps or less, no problem. Less than 4 milliamps. 4 milliamps, it starts the opening process. So meaning it will open before it hurts somebody. Any question? Can I get thumbs up that we know how it works, that boy? GFCI, I'm sure a lot of us have done it. Looks like this. You have line side. Okay, the other thing I want to emphasize, guys, when you have a GFCI, you're going to have the line side or the load side. So you put your line in, line out, line side, load side. You can have a GFCI, guys, with circuit breaker like this. So, but be very careful when you do a circuit breaker. You're going to bring your power in. So out here, as you guys know, you're going to have you're going to bring the you're going to break the neutral and the ground, So you tie this one to the neutral side, and from here you take a hot and a neutral, Here's a mistake number one when we wire these guys, is people take the neutral and tie the neutral directly to the neutral bar. This wouldn't work. So you plug it in, this little extension here, you tie it to the neutral bar. So now you have the hot and neutral getting into the GFCI. Out of the GFCI circuit breaker, you take 2 wires, one hot and one neutral. Can I have thumbs up? We know how to do that, Chad. Same thing for ARC. GFCI. Here's what GFCI is, guys. I can't emphasize when you do the wiring is, of course, you have to have GFCI in out. If you don't do it in this format, it wouldn't work, right? So can I have a thumbs up, Chad? We know what the line is side and the load side here. Cool. Line load. If you want it to protect, you mix the line, you take the neutral from here, you're screwed up. It has to be hot neutral in, hot neutral out, in that order. You bring the hot to the load and you take out to the line. That's it. Also would trip. So in, out. You can feed, this is called feed through, guys, GFCI protection, feed through, to make it cheaper for you. You bring, so anything anything here right now, everything in this area is GFCI protected. Does that make sense? Anything, including anything plugged in the GFCI, anything downstream is GFCI protected. Thumbs up, Chad. We know how to do that. Cool. Might as well jump to the commercial and call it a day. If you guys are, look at mistake number one when you wire. Look how this one, improper wiring. How you can do a lot of improper wiring with these devices. Look how this one right here. Can you see why this wire here have to be coming from? You can't bring that wire directly from here, so it's going to trap. So proper wiring. Look where you bring the wire here. I don't know if you guys can see that. From this point, you have to move it right to here. Okay, in order for the system to work. Your GFCI have to be monthly tested. So this is a log where you can test them. Anybody test their GFCI? In 2011, guys, the code requires all GFCI receptacle to be readily accessible. 2011. So I no longer can put my GFCI on and for a garage door opener. You have to have a GFCI, right? You can't put it in the garage now because it's not readily accessible for short people. So you have to put the GFCI on the wall and feed through, or a trip GFCI, just a face that has GFCI buttons. That's 2011. All GFCI have to be what? Readily accessible, meaning you can't have to use screwdriver or climb over or put a ladder. You have to just walk in and push the button. That's what readily accessible. So keep this in mind. This is QP arc fault circuit interrupter, I believe, right? So my QP arc fault circuit interrupters looks, or is it GFCI? Anybody? Where's the CP hackers? So this is my arc fault circuit interrupter. Jumping into the arc fault circuit interrupter. Yep, arc fault circuit interrupter. It looks exactly like the GFCI, guys. In, power, out. So you tie this to the neutral and you pull out of the circuit breaker neutral and hot. I want to, since we have this, I want to bring to your attention, guys. Can you see what the terminal rating on these receptacles? Do you see 75? So these, not receptacle. Circuit breaker 75. And do you see that it's rated for copper or aluminum? So, but anyway, so this one is your 15 amp arc fault circuit interrupter. It runs you what? $40 or so. There's a couple of testing. This device, actually, anybody have one of these? You can test the wiring. You can push this one, see if it GFCI trips. Push with this one, it creates an arc. Inspector use them all the time to test, and this will test if your neutral is wired right too. So this is a couple of testers that you can use. The inspector use them to wire things. Fancy stuff. Tamper resistance. This is your tamper resistant, right? Just a quick review. Required everywhere. Here's another tamper resistance, decorative type. Weatherproof. Here's weather resistance. You'll have WR on it or TR. Tamper resistant TR, WR. This is how you're going to buy that. So tamper resistance, just be aware everywhere. Tamper resistant GFCI. This boy can get you tamper resistant GFCI. Is it weather resistant? Okay, look at that. Tamper resistance, GFCI, weather resistant. That will run you $22 or so. 20 amp. I think it's even more if it's 20 amp. So if you're outside, you have to have a receptacle, a GFCI first, or GFCI protected. You have to have tamper resistance and weather resistance, right? And in-use cover. Everybody okay with that one? All these requirements, so they have one for you. If you have receptacles, no, I can't cut these. If you have receptacle, guys, like these, now here's what happened. If you have old receptacles with non-grounding type receptacles, how can you change them? You can change them with an old one with an old one non-grounded, option 1. Option 2, you can change them with GFCI. Option 3, you can change them with a receptacle that looks like this one, fit from a GFCI though. And you have to put a label right here that says, no equipment grounding conductor. One more time. You're changing receptacle like this. Option number 1, buy another receptacle non-grounding like it, stick it there. Option number 2, put GFCI receptacle right here. Make sure you put a label. It comes with it. No equipment grounding conductor here. Option number 3, have one like this. put it in here, but it has to be fit from a GFCI, which just makes it hard. So these are the options that you have for typically most of the time. What I've done there is just put a GFCI receptacle with a no equipment grounding conductor. So these are your connections, equipment grounding conductors. And when we talk about portable plug-in, guys, with GFCI, this is what they're talking about. They use in construction sites. They have GFCI protection. Here's another portable rated. So what this is required, if I'm busting this wall right now here, and I'm using this receptacle to drill a hole in this wall and busting it doing construction, I have to be plugged into GFCI. Or if I just want to use this permanently installed receptacle, I have to go change it to GFCI, or I have to use a system like this, plug it in where you have to have GFCI protection. This is OSHA too. It's nothing new. Okay, a couple of examples. We talked about this one. Surge protective devices, guys. Surge protective devices. Here's how they work, and you guys familiar with that one. They look at the surge. Let me just give that little surge here. When they see the surge here, they take it down and shunt it. They take it down and shunt that surge. So SPD will shunt them directly, so they don't let them go through. Can you guys see how what went through is just not that little arc, just that's the signal. The way they do them, guys, they make devices so close to each other that the voltage will jump if it's too high. And what is a pulse? A pulse is a very high voltage for a short amount of time. It jumps and it goes to the ground. So that's your protection. Here's how it looks like. Is it required by code? No. Is it good application to have a receptacle like this? Yes. Required? No, it's not required. In 2011, Darren, there's a proposal to require every service panel. This is just a receptacle format of it. Here's another plug-in format. Here's what in 2011 they want to require you. In 2011, I don't know if it's going to pass. They're going to require every panel, main panel, service entrance main panel, to have a surge protective right at the main panel. Right now, this is industry standard engineered project. Every engineered project I worked on, it's industry standard, where the main panel, they put surge protective device in it to protect the whole building. As a matter of fact, we go downstream and we put surge protective in downstream panels. So what they're trying to do in 2014, the coming code, they want to put this one in the code. Right now, engineer project, when you engineer project, 3-phase, 482, 208, standard, a lot of engineering firms, they stick required a surge protective device in the main panel only. So it comes built in the panel. So when you buy it from Square D or Color Hammer or GE or Siemens, they build it right into it per your specification. Engineer project. Cool? So that's what they do to protect the whole system. So in surge protection, guys, there's lines of defense. Line number 1 at the service, and then line number 2 at the sub panel, and line number 3 right at the device. So what they do is, here's the surge. You come over here. Here's my surge, and this is my nice voltage, right? And what they do is, at the service, they cut this. That's right at the service. Then you go downstream at the panel, they cut a little bit more. And when you go right at the receptacle level, it cuts the rest of it. So they use multiple levels of surge protective devices. That's if your building has a lot of electronic equipment, and that's the perfect application to have different levels. What you're looking at right now is level number 1, right at the surface. This level will be the receptacle, the one that we just looked at it, that surge protective device receptacle. Can I have a thumbs up that we understand that surge protective devices required by code? No. Recommended by engineers like yourself all the time, commercial, industrial. But we're doing residential. We don't do a whole lot of that. Effective shock. These are just a couple of circuits. This is arc, a couple of arc things. Okay, the last thing, guys, I wanna mention is there's a couple of wiring here. This example of wiring, I encourage you to go there and do some wiring for this. There's a couple of wiring in the back, so please go ahead and do it to exercise. Any comments, any questions? Any comments, any questions? Before we leave this chapter, here's the outcome. You guys need to know how the GFCI works and where you need it in residential and commercial even. Number two, arc fault circuit interrupters, how it works, what does it protect from, and where do you need it? Surge protective device, how it works, and do you need it by code? No, it's recommendation. So if you got these three, you're good to go in that chapter. And a couple of wiring in, out, and so forth. Aaron, my friend, too much, too little? Good? Did I take more than half an hour? Okay. Thank you, guys. And again, I don't... All right.